Hello, my name is Muhammad Hadi Aiman bin Hamid Maesa from class DCE 2A. My matrix number is 33 DCE 20F 2005. Now I would like to present about simulation severity of quenching. The objective is to study the hardness of medium carbon steel samples and their microstructures under the following conditions: as received, anneal, normalized, water quench, ice quench, and oil quench. Apparatus that we will use is 6 medium carbon steel samples, furnace at 90-100 degree Celsius, tongs, wet rock well hardness, testing equipment, beakers, oil and ice quenching mediums, optical microscope, polishing machine with abrasive, bed grinder, abrasive paper, flat glass plate with wooden framework, electric hot air blower, carton, neutral reagent, Rockwell hardness testing machine. So step 1 is obtain 6 identical samples of medium carbon steel and keep one sample aside as the control sample. Annealing, normalizing, water quenching, ice quenching, and oil quenching. Step 2, austenite all 5 samples for 30 minutes at 900 degrees Celsius. So we turn on the furnace. We set the furnace temperature at 910 degrees Celsius. We open and we put all the 5 samples in furnace. So we close the furnace and we wait until 30 minutes. After 30 minutes, we turn off the furnace. Step 3, remove the sample from the furnace and quench them in different mediums. First, we quench in oil. Second, in water. Third one, in brine. The fourth at room temperature, and for the last sample we let it cool in the furnace until 400 degrees Celsius. Note: once all samples are cooled to room temperature, each sample is polished and microstructure is observed under a microscope as shown in the subsequent steps. Why is the sample austenized for 30 minutes? The sample austenite for 30 minutes because we need to uniform austenitization. Step 4, obtain a flat surface on the specimens by back grinding. Step 5, support a polished paper 1/0 fineness on a flat glass plate. Polish the specimen rubbing in forward direction only. Step 6, finish polishing the specimen on 4/0 abrasive paper. Wash hands and specimens. Step 7, do the fine polishing on the disc polishing unit. So we turn on the machine. Note: after fine polishing, clean off the polished surface of the specimens with water and dry it with an electric hot air blower. Step 8, etch the specimens with 2% nitrile reagent by swabbing for a few seconds. Wash and dry. Step 9. Examine the specimens under the microscope and observe the structural features. Okay. Zoom. We can zoom 500 times, and this is the result. The question: which medium give the most severe quench? So we need to look first. So medium give the most severe quench is ice brine. Step 10. After noting the microstructural feature of the samples, perform the Rockwell's hardness test using the cone identer for all 6 samples. Step 12. The major load is set and the motor is switched on. The hand lever is kept in load position for 15 seconds. The reading is noted down using C scale. Step 13. So values are noted for all the 6 specimens. So based on the table, we can see that ice quench have the most Rockwell hardness number, while as received none is the basic. So it has the lowest Rockwell hardness number. So the observation is untreated as received. So we view sample. The hardness values obtained can be correlated with the microstructural observation. Higher fraction of martensite are observed in better quenchants, thereby resulting in higher hardness value. That's all from me, Hadi Ahmad. Thank you.